In this video, we're going to talk about parallel lines and angle pairs. So there's the corresponding angles postulate, the alternate interior angles theorem, the alternate exterior angles theorem, and the consecutive interior angles theorem. So let's just review those and go over some examples. The corresponding angles postulate states that if two parallel lines are cut by a transversal, then pairs of corresponding angles are congruent. So we have parallel lines L and M cut by a transversal, and we know that these corresponding angles would be congruent. The alternate interior angles theorem states if two parallel lines are cut by a transversal, then pairs of alternate interior angles would also be congruent. So we have two parallel lines, they're still cut by a transversal, and they would form alternate, meaning they're on opposite sides of the transversal. Interior just means they're inside of the pair of parallel lines, and we call those congruent. So like if this was angle A and B, we could say angle A is congruent to angle B. Same thing here, if this was A and this was B, we could state that angle A is congruent to angle B. Then we have also alternate exterior angles theorem. It just means that if they're exterior and alternate, they are still congruent to one another, just like the alternate interior. So alternate exterior and alternate interior angles are congruent. So we have parallel lines L and M cut by a transversal. These are alternate because they're on opposite sides of the transversal, but they're exterior because they're outside of the parallel lines, and they would be considered congruent. So we could say if that is A, that's angle B. Angle A is congruent to angle B. All right, in our last theorem, it's consecutive interior angles theorem. Consecutive means the same thing as same side, which sometimes just sounds like it makes more sense, but they usually use the word consecutive in problems. They mean the same thing. All right, so if two parallel lines are cut by a transversal, the pairs of consecutive interior angles are supplementary, which we know that means they add up to 180. So we have parallel lines cut by a transversal, and these angles sit on the same side, so they're not alternate. Notice one has a tick mark and one does not. They are not equal to one another. They just would add up to 180 degrees. So they sit beside each other. That's why we call them same side. They're on the same side of the transversal. Consecutive kind of means they sit beside each other. They're like one after the other, and they add up to 180. So we would say that if this is A and this is B, angle A plus angle B would equal 180 degrees. Okay, so let's just take a look on the next page. We need to recall that vertical angles are congruent. So if you have a pair of intersecting lines, the angles that are opposite of one another are congruent. So angle FEG is congruent to angle IEH. They're both 134 degrees. And the same thing happens on the opposite angle that's across from one another. So they're directly across from each other. And it's just when lines intersect. Then we also have a linear pair that can happen. So a linear pair is when you have two angles right beside each other and they form a straight line. So they're adjacent to one another and they form a straight line. So they add up to 180. So let's say angle 1 plus angle 2 would equal 180 degrees. They are supplementary. It's a special type of pair of angles that form a straight line. Okay, so now we're ready to look at some examples. So in example 1, it says if P is parallel to Q and the measure of angle 1 equals 105 degrees, find the measures of all the angles formed by parallel lines cut by a transversal. All right, so if we have line P is parallel to line Q, they're cut by this transversal, and then we know that the measure of angle 1 is 105 degrees. I'm just going to focus on the picture of this for a minute. So 105 degrees is angle 1. It's a vertical angle to angle 7. So that would also be 105 degrees. We can tell that it is corresponding to angle 3. So that would be 105 degrees. Angle 3 is vertical with angle 5, or you can consider angle 5 is corresponding with angle 7. But either way, those are all 4 going to be 105 degrees. And then we can look at angle like 2 and 8 in this first like upper intersection of the transversal. If we say that angle 1 and angle 8, they're right beside each other and they form a straight line, then they are a linear pair. So we could say 180 minus 105 gives us 75. And that would be angle 8, which would also be angle 2 because they're vertical angles. Angle 8 is corresponding with angle 6. So that makes that one also 75. And then angle 4 is vertical to angle 6. So that takes care of all of the angles. Let's just fill that in our answers over here. So let's see. 1 was 105. So was number 7. And 3. And 5. And then the other 4. So 2, 4, 6, and 8 were all 75 degrees. Okay, in the next example, it says if DC is parallel to BA, are the angles congruent or supplementary? Notice these are segments this time. It's not a line because there's not arrows on the end, but we can still use these the same way. So we're just looking at different angle pairs. So if we look at DHG, I like to say DHG and then put the angle in the middle. And then HGA, so H to G to A, put the angle in the middle. These look like they are alternate because they're on opposite sides of the transversal. They are interior because they're inside the parallel lines. And alternate interior angles are always congruent to one another. Okay, so let's try the next one. So FHC. F to H to C is right there, and DHG is the angle right here. So those two angles I have labeled appear to be across the intersection of those two segments. So those would be vertical angles. So I like to write what they are, and then that they are congruent or supplementary. So those are congruent because they are vertical angles. All right, let's look at the next one. BGE and FHC. So BGE and FHC. So these are exterior angles because they're on the outside of our parallel lines. And they are alternate angles because they are on opposite sides of the transversal. So let's write that down. Alternate exterior angles, and therefore those are congruent. Okay, moving right along. Let's look at number 3. EGA, so EGA is right here, and GHC is right there. These appear to be on the same side of the transversal, but they're not consecutive, because consecutive would mean that that angle HGA would be involved, but it's not. So these are corresponding angles. And corresponding angles are always congruent. So we'll go with that one. Number 4 says AGH. Let's see, AGH and EGA. EGA. These two sit right next to each other and they form a straight line. So I would call those a linear pair. And therefore, those are supplementary. They're not equal. They just add up to 180. Okay, and the last one is DHG. Let's say DHG and BGH. So BGH. So these are on the same side of the transversal and they are right beside each other. So they are consecutive interior angles. So consecutive, which sometimes we see it called same side, and they are interior angles, and those are supplementary. They are not equal. So they are supplementary, and linear pair was supplementary, and the others were congruent. Okay, so we just have one more example to work through. This one says solve for x and y and explain your reasoning. So when you look at this picture, you might notice that this one has 4x minus 8. This one has 3x plus 10 as the angle measure. This one has 11x plus 2y. So when you're looking at this problem, you can't solve for x and y at the same time. We need to use the ones that only have one variable involved, which would be those two. So 4x minus 8 and 3x plus 10, we can relate those two, and we'd be able to solve for x, and then we'll be able to figure out y because we know what x is equal to. All right, so the two that we have to work with that both just have x are alternate, because they're on opposite sides of the transversal, and they're exterior because they're outside the parallel lines, and those are always congruent to one another. And so to solve for x, we can just set 4x minus 8 equal to 3x plus 10 and solve for x. So let's subtract 3x from both sides and bring down x minus 8 equals 10 and add 8 to get x equals 18. All right, so now that we know what x equals, we're able to go back and solve for y. So I would just take these two down here at the bottom. They're right beside each other, and they form a linear pair. So when we have a linear pair, those are supplementary. So I'm going to write linear pair. Those are supplementary. So let's say 3x plus 10 plus 11x plus 2y equals 180. But we could go ahead and plug in 18 just to help make this a little easier. So that would be 54, 3 times 18 plus 10. So 3 times 18 is 54, plus 10 gives us 64. So let's say 64 plus 11 times 18 plus 2y will all add up to 180. 11 times 18 is 198, so now we get 64 plus 198 plus 2y is equal to 180. 64 plus 198 would be 262. Then we can just subtract 262 from 180. So we get 2y is equal to negative 82, and we just have to divide by 2. And so we end up with y equals negative 41, and we have x equals 18. So that's it for your notes. There is a video attached for another take on parallel lines and their properties. So feel free to watch that if you need a little more reinforcement. And thank you for listening.